we're going to let u equal 8y plus 1. So du is equal to 8 dy. I have a dy here. Get rid of the 1/8 by multiplying by 1/8. So the 1/8 comes out in front. It's going to be pi over 16, because pi over 2 times 1 over 8 is 1 over 16. And we're going to change the limits of our integration. I'm going to do this in, let's see, have you tried blue, pink, orange? Okay, we tried all of them. Starting at 0 here, when y is 0, it's going to be 1. And then let's use blue this time. At y equals 2, that's 16 plus 1 is going to be 17. So we're going to change the limits of integration so that we don't have to back substitute. Pay the price up front so that you don't have to do it in the back. This becomes square root of u du. That was our u, and then du is equal to 1/8 dy, and then factor it out. So what do you do from here? That's going to be u to the 1/2. Integration of that is going to be u to the 3/2 and times 2/3. So it's going to be pi over 16 times 2/3 times integral. Now we just integrated that. It's going to be u to the 3/2 and evaluate it from 1 to 17. Cancel this out, becomes 8. So pi over 24 times 17 to the 3/2 is the same thing as 17 times square root of 17. If you're not familiar with this, try to change it into radical form. It should not be 17 root 17. 17 radical 17 minus 1, because the cube root 1 to the 3/2 is, I'm going to work it out for you, is the square root of 1 cubed. That's how you change it to radical form. The denominator becomes the index. The numerator of the exponent comes to the outside. The square root of 1 is 1. Obviously, to the 3 power is 1. I think that's the answer. Yeah, I can't see the answer, so seems to be right. Okay, so there it is. The last problem, it's a little bit difficult. First time I tried it with my student, I missed an R somewhere. So let's try to figure this out. This is problem number 28. So you have two parametric equations, x equals r cosine of t, y equals r sine of t, show that the area of a sphere, the surface area that is 4 pi r squared. As I stated earlier, you're given this formula in geometry. I also teach honors geometry to about 7 students, and they're actually given this formula all the time. So this time we're going to prove it. It's a proof. Okay, I'm going to prove it out using calculus. So let's get started. We're revolving around. Before we start though, how do we know that this is the equation of a circle? We know that the sine squared of t plus the cosine squared of t, that's the Pythagorean theorem, in trigonometric form is always equal to 1. Solving for cosine of t is equal to x over r, sine of t is equal to y over r. So cosine sine squared of t is y over r quantity squared plus x over r quantity squared is equal to 1. Y squared over r squared plus x squared over r squared is equal to 1. Multiplying both sides by r squared, x squared plus y squared is equal to r squared. And we know that from geometry to be the equation of a circle. So it's in the parametric form. We're going to try to change it into regular form in terms of x, y, to get rid of the parameter t. You can do it using parametric equations if you want to, but I elected to do it my way. Oh, I have it right here. Okay, so I'll draw this out for you a little bit. It's a circle like this. That's negative r plus r, and we're going to spin it around the x-axis here. As we spin it, we end up with something like this, and so it's going to be a sphere. We're trying to find the surface area. The surface area formula is going to be 2 pi integral from negative r to r, of the y times the square root of 1 plus f prime of x squared dx. I hope you can see that. I'm going to move it just a little bit, okay, for you guys. So that's what we're trying to find, and hopefully it'll come out to be 4 pi r squared. Like I said, we're going to pay the price up front a little bit. This might take 2 pages, so bear with me a little bit. So what do we do? Oh, we have to do this one first. Before we do that, we're going to get rid of the parameters here somehow. How are we going to get rid of the parameters? Oh yes, we did get rid of the parameters. X squared plus y squared equals r squared. So we have the equation x squared plus y squared is equal to r squared. Solving for y, we move the x squared to the right side. Y is equal to the square root of r squared minus x squared. We have to take the derivative of that, y prime. It's to the 1/2 power, so move it on down. So it's 1 over 2 times r squared minus x squared to the 1/2 times the chain portion, which is negative 2x. Notice that the negative cancels. You end up with y prime is equal to negative x all over square root of r squared minus x squared. And now what we're going to do is we're going to square the left side, square the right side. You end up with y prime squared is equal to x squared over square root of that squared is going to be r squared minus x squared. So I hope you can see that it's going to be, x squared right over here, x squared over r squared minus x squared. So what do we do from here? Oh, we're going to go 1 plus that. So we're going to use our blue right here and go 1 plus that. We're going to add 1. Have a common denominator, so it's going to be x squared over r squared minus x squared plus r squared minus x squared over r squared minus x squared. That's 1 right there. Notice the x squares cancel. You end with r over r squared all over r squared minus x squared. And the last thing we're going to do is we're going to use, I don't know, orange. Square root that. So that becomes, the square root of r squared just becomes r in the numerator, and you end up with r squared minus x squared. I'm going to rewrite this really nicely for you up here, okay? So the surface area is equal to integral from negative r to positive r, 2 pi, factor up to 2 pi, and then y, our y value was right over here. That's our radius, not that r, square root of r squared minus x squared times r over the square root of r squared minus x squared dx. Notice that the r squared minus x squared cancel. Factor out the r, you end up with 2 pi integral from negative r to r of dx. Oh, we've got to take out the r. The r is constant, it's not a variable, so we can take it out of the integral. The integral of dx is just going to be x, 2 pi r, x, I'm going to evaluate it from negative r to positive r, using the fundamental theorem of calculus part 2, 2 pi r times r minus negative r. R minus negative r is 2r right there, times 2 pi r, 4 pi r squared. QED, guys. It takes a little bit of persistence. I'm going to draw this right. Oh, I did it in one page too. It takes a little bit of persistence, but if you work the problem out ahead of time, it's going to be a lot easier when you actually do the problem, because you're going to rewrite the problem over and over and over again. It's easier to work the problem in separate pieces. Okay, you got a big problem, break it up. It's a good rule to have.